Hello, Curly Solali here. In this video, we're going to take a look at different kinds of operators and making comparisons along with our decision structures. And this will make things quite a bit more interesting. In this video, we're going to take a look at comparison operators. And these work hand in hand with decision structures to help you code logic in your scripts and your programs, to help you make decisions with your code based on the results of, return values or function outputs or something like that. So I'm going to go through these briefly and hopefully not too slowly. But if you need to pause the video, and pull it full screen to look at the code, please do that. If you need to take a moment, try each one out. Follow each example. I'll put the source code that I can up underneath the video in the description tag, but I think you can only put about 5,000 characters there. So until I figure out someplace else to put the code for these projects, maybe GitHub or something, I don't know. Eventually I'll get that part figured out, but for now, if you need to, you can always pause the video and put each of these inside of ICE if you kind of want to, pick it apart, see how it works, play with it. But I'll try to be brief and I'll try to step through these fairly rapidly. So just pause the video if you need to. That's the great thing about videos. Unlike having a live instructor, you've got the remote, so to speak. You can pause the video when you need to. Okay, so the first thing we want to look at in this case is greater than and less than. Those are pretty basic operations, right? So let's grab this first block of code here. And we're going to run this. Okay, so what are we saying? Is 5 greater than 7? Well, in some languages, mathematically, you'd see this, 5 greater than 7. But in this case, everything that is a comparison operator, has a dash in front of it in PowerShell. And it's usually just the first two characters. So greater than would be dash GT. Less than would be dash LT. Equals would be dash EQ. Or not equals would be dash NE. And so forth, okay? So in the condition portion of our if statement, if 5 is greater than 7, well, is that true? No, it's not. 5 is less than 7. So would this portion of the code be executed in these curly braces? No, it would not. Rather, because that is false, this portion of the code would be executed in these braces. And if we run it, I'll just click on run it, we can see that's what happens, right? 5 greater than 7, false. 5 is less. That's what it displays. Okay, I'm just gonna drop down a couple of lines here too for our next example. But all right, so let's do this. That's if 5 is greater than 7. So is 5 less than 7? All right, so instead of dash GT, it's dash LT. And if we run the code, 5 less than 7, true. It is less, right? This condition, the test portion, along with the less than operator, evaluates to be true. 5 is less than 7. And so this portion of the code would be executed. So hopefully that makes sense so far. You can hear my daughter's budgies chirping in the background. They're happy about something. All right, let's look at the next example. And we're just going to do a comparison here with the equals operator. So I'll throw it over here in our test section, minus our brace. A is 10 and B is 10. So, equivalently, they're the same value, both string-wise and numerically. Is A equal to B? So we're using the dash EQ, the PowerShell equals operator. And in this case, well, yes. So this block of code would get executed. If that were not the case, then this block would be executed, right? And just to make things neater, I'm going to add a couple of lines down here too. Just using the escape sequence for a new line. So if we run it, is A equal to B? True, A equals B. Now, what if we do this? What if all of a sudden A is 12? Good grief, what a tweet. In this case, false, right? because they're no longer equal. So just following that equals operator there. And let's take a look at our next example. So test result, we assign the value midichlorians, and we store it in the variable test result. This time we're looking at a string. If test result is not equal, okay, this is -any, that's not equal to midichlorians, then what? This child will not become a Jedi. Else, in this case, this would be if what? If test result does evaluate to be midichlorians. In that case, the force is strong in this one. Become a Jedi, this child will. All right, so I'll try to say that like Yoda says that. But all right, so if we run this now, the force is strong in this one, become a Jedi, this child will. That's our output over here. Why so? Well, look, in this case, test result is midichlorians. If it's not equal to midichlorians, we'd say something else, okay? This child will not become a Jedi, but because it is equal to, it evaluates to, that string evaluates to midichlorians, then this part of the condition, this test, it returns false. And so therefore this block of code is executed. All right, so in this case, become a Jedi, this child will. The force is strong in this one. But if I change that to no midichlorians, if the kid had no midichlorians, then what happens? This child will not become a Jedi, right? Because now this portion of the test condition, this block of code is executed because it's true. And moving on to the next example, we'll try not to drag this out, but there's basic arithmetic operators that you can use in calculations, just like you would with any calculator in PowerShell. And these come in useful when you're doing formulas and calculating things out. So we'll throw this over here. And in this example, we're adding 3. So 3, we're going to add 5, and then we're multiplying by 10. Now, the same rules of precedence that apply to mathematics, that apply algebraically, also apply in programming. So remember that the order of precedence, things like multiplication and division, have a higher precedence than addition and subtraction. Okay? Or they bind tighter. And it's the same in programming. Now, you can alter that precedence if you want to by using parentheses. A parenthetical expression will alter the default precedence. And so if I wanted to interfere with the natural precedence order of multiplication and division being greater than addition, I could take a set of parentheses and wrap it around. And if I did that, in this case, then I would add the 3 and the 5 and then multiply that by 10 with those parentheses. But if I don't add the parentheses, then the result would be to bind these together first. Now let's look at this example. 10 minus 4 divided by 2, the same precedence rule applies. All right, so 4 divided by 2. Now this operator is unique to programming, but basically it simply returns the remainder after division. Okay, so in this case, after we divided that number 13, by 2, what's the remainder that would be returned there? So if we run this, let's go ahead and run this. We'll use under the default precedence. Okay, so looking at the first example, does that look right? 5 times 10 is 50 plus 3, that's 53, right? That's the default order of precedence because multiplication binds tighter or has a higher precedence than addition. Now in this example, same thing, division has a higher precedence or binds tighter than subtraction does. So first we divide the 4 by the 2, and then we would subtract the 2, the result of that, from the 10, and that would leave us 8, right? So what about this example? In this case, we want 13 modulus 2, okay? So if we divide 13 by 2, what do we get? In this case, 12. So if we divide it by 6, we get 12. What's the remainder that's left over? The remainder would be 1, right, to make the 13. So modulus operator, it's useful for things. One of the things a lot of programmers, developers use it for is telling if you have an odd or an even number. And you can do all kinds of other things with it too. But you know, if you're dividing something by an even number, you have no remainder. If you're dividing something by an odd number, you'll have a remainder left over. Let's look at modifying the precedence order. So say we wanted to change the precedence order. I'm going to wrap parentheses around the 3 plus 5, and I'm going to wrap more parentheses around the 10 minus 4. So now we're changing or sort of violating that natural precedence. We're overriding it. Instead of violating, overriding it. But okay, so now because we did that with parentheses as a parenthetical expression, 3 plus 5 is 8. 8 times 10, it's 80, right? And now 4 divided by 2 is 2. 10 minus, so if we were to not overwrite the precedence, we wouldn't be getting 3 here. But because we use parentheses, now we're subtracting the 4 from the 10 first. 6, and 6 divided by 2 is 3. But again, if we pull out these parentheses and run it mathematically, 53 and 8. Okay. Now you can also use parentheses to change the portion of code that you want to execute first. There are certain defaults when you call one function within another. When you're using a recursive algorithm, or you're plugging the return result of the end of one function into the, as a parameter to another function. So you can also use a parenthetical expression or parentheses to modify the precedence value of that. But that will be a video for a later time. And we'll take, for now, sort of as an introduction to the concept, we're just talking about using parentheses to modify the default precedence in PowerShell mathematically. Later, we'll see that we can do the same thing with whole sections of code and functions by placing them inside of parentheses. Okay. Oh, let's see. Okay, these are assignment operators, and we will go through this. All right. Let me throw this example here so we can just kind of focus on this block of code. Okay, now these are sort of shorthand methods of concatenating and doing things to strings. And let me show you what I mean by that. So here we have pony age. Pony age starts out as 5, okay? And we're going to display that here. Pony age is, we're concatenating the string value here of this variable, pony age. So first things, the first part's going to display 5. Now here we're doing something. And in this case, we're using the addition and an assignment operator. It's what's called an overloaded operator. And an overloaded operator is like basically the assignment operator or a mathematical operator like addition or subtraction, but it's basically put together and it's overridden. So there's actually a function. There's a block of code that runs behind the scenes when we use this operator. So it's more like passing it, into a function or a method, which we could do like this and like this, and that'll become clear when we do functions. But so this right here is actually the name of a function. There's a hidden block of code that's built into PowerShell. But in this case, this is equivalent to, all right, let me add some lines here. So this line here, right, plus equals 5, is equivalent to doing this. This is what we call accumulation or an accumulator. And there's nothing wrong with, in your code, you could do it either way. There's no disadvantage performance-wise. But this is, kind of more shorthand code-wise. It's less typing. So when you do a lot of accumulation, when you use a lot of accumulators in a script or in a program, a lot of times, you prefer the shorthand method. So you'll use this overloaded operator. So just remember, if you see that plus equals, it's a quick way of coding or saying that pony age is equal to itself, whatever its value is, plus 5. Okay? These two statements here do the exact same thing. you know, they both are basically an accumulator. They're taking a variable, whatever its value is, and adding whatever amount we pass in this case of 5, to the variable itself, okay? So it's just a common practice in code. And matter of fact, I'll even show you, I'll tell you what, let's run this. We're gonna comment this section out. Maybe that was just, maybe we should focus on less code at a time or something. I'm still trying to figure out the best way to do this, guys. My goal is to not be confusing and to make this easy. And I you know, I apologize if it. I'm trying to learn how to present this material in the same way that you're trying to learn it. Hopefully more efficiently. Hopefully in a way that's digestible and easy to assimilate. So let me move this comment tag here. Okay. All right. So remember, these are just comment tags, right? So the first time I'm going to show you the overloaded addition and assignment operator here. So, all right. So pony age starts out as 5 up here, right? That's what it says here. Current value pony age is 5. What do? We accumulate 5 into the variable. All right. So we add 5, and then what's our pony age? 10. Okay. Well, we're going to comment this line out, and now we're going to do this. Okay. So we're not using the overloaded operator. But essentially we get the same thing. There's no difference behavior-wise. Okay. Now there are additional overloaded operators that this works with. So for instance, when we go into the section on arrays, when we get into the videos dealing with arrays, you might instantiate or build an array of some, you know, undetermined value or some undetermined number of elements. And then what you could do is you could accumulate objects or add objects into the array inside of a for loop. And you might say, and we would say, you know, we'd say like some object, and it would have like an index value. All right. So if that looks like gibberish to you, and you're like, what the heck, Carla, what are you doing? Don't worry. When we go through arrays, well, that'll become very clear. But I'm just trying to, you know, break this elephant up into little bite-sized pieces here. So I'm just trying to make the case for, you know, uses of different uses of, or things you might use this overloaded assignment operator for. Okay. But for now, we're keeping it simple because we haven't covered arrays yet. And so it's enough to say that these two statements of code are equivalent. But obviously this code is shorter, is it not? Okay, so hopefully that makes the point. All right, I'm going to... Okay, so let's pull our comment tags out and look at the rest of this code. And... All right, so in the same way we can do addition and assignment here, right? We can do minus an assignment here. We can do multiply an assignment here. We can do divide an assignment here. Okay, does that make sense? And here we're just gonna set pony age to 13. All right, so we're just basically setting the value, simply setting the value, regardless of what we've done before. Pony age is 13, and then now we're going to use the modulus operator. What would that do for us? It's going to provide for us the remainder, right? So if we did that, you know, what would the result be? Let's run this script and we'll go through it. Okay, pony age is 5, pony age is 10. We went over that. Now, what are we going to do? All right. We are subtracting 5, and that works as expected. Pony age is now 5. Okay, so if pony age is now 5, and if we multiply by 5 and assign the value, then how old is our pony? That works as expected, 25, right? And here we're just going to do the opposite. Now we're going to divide by 5 and reassign it back to the same variable. So now we end up where we started from. Our pony age is now 5 again, after doing all of those mathematical operations. Okay, so we're going to set pony age to 13. That's our initial value right here. And that's where we're assigning the value 13 here. And now what are we going to do? Now we're going to use the modulus operator. Pony age, which has a value of 13, modulus, and then assignment 5. All right, so what's going on here? Well, if we don't want the dividend or the quotient, but if we divide the 13 by 5, how many times would 5 go into 13? Twice, right? 2 times 5 gives us 10. Well, how many are left over? What's the remainder? 3, exactly. You don't hear the voices? You don't hear the voices? I'm talking to you. No, I'm just kidding. But the remainder is 3. Okay, I'm imagining that you're talking to me. I'm lonely. Oh, please, viewer, talk to me. Talk to me. I'm so lonely. Please, please just talk to me. I'm terribly lonely. Okay, tangent. Squirrel. All right, sorry about that. Focus, Curly. It's hard to script a program when you have ADHD, and it's even more difficult to try to teach it. Okay, back on task here. All right, let's add an example here of the assignment operator and of using equals and not equals with string values. Okay, so we're gonna set the values of some strings, and let me get rid of that pony age there. We don't need that. We'll keep the rights in here because I like adding those extra lines. Okay, so we have ground force covenant is initialized with a value of not present. Okay, it's a string value, string data type. We have ground force banished, and it's initialized with a string value of present, so not present, present. And then we have ground force United Nations space command, all right, initialized with a value of present. If ground force covenant is equal to, right, we're using the equal comparison operator. So if this is true, this portion's true, then the covenant are present in this location. Otherwise, if it's false, the covenant are not present in this location. If ground force United Space Command equals present, is it present? Yes, in this case it would be true, then this block of code would be executed. So UNSC are present in this location. Otherwise, false, they are not. That block of code would be executed. Here, we're using not equals. So it's the opposite. If ground force banished is not equal to absent. So is ground force banished absent here? No, it's present. So as long as they're not absent, as long as they're present or any other value, they could be banana, then we would say the banished are present in this location. Otherwise, the banished are not present in this location. So let's run this and change the values and see how these operators work. Covenant are not present, UNSC are present, banished are present in this location. Well, let's take a look at ground force banished. Right, we're seeing if they're not equal to absent. Well, they're not, right? The banished, the value of it was present. So we're saying they're present in this location. What if I changed it to banana? Make Gwen Stefani happy. All right. In this case, ground force banished, they're still present. Why? Well, it doesn't say they're present. The string, the value banana, but in this case, the test condition doesn't care. When we use not equals, all we're saying is, I don't care what the value of this is, as long as it's not absent. So we could, supercalifragilistic. And the banished are still present in this location, right? Why? Because it's not absent. But what if we do match that string value? What if ground force banished becomes absent? then this test condition would finally evaluate to be true. So rather than this block of code, this is the block of code that would be executed, right? So now look, the banished are not present in this location. Does that make sense? I hope so. I don't make sense, but I hope PowerShell makes sense. Okay. All right, ground force covenant not present. Okay, so they're not present. So they are not present in this location. But what if they are present? Ground force covenant, if it equals present, then watch what happens when we run the script. They are present in this location, right? So this block of code would be executed. Why? Because now it's true. And this is just the opposite of not equals. It doesn't care what value we assign. We could assign any other value, and this would always be false. This is only going to be true in this case if the value matches present. And on the other hand, this is only going to be true, or this will only be true as long as it's not absent. Okay. If I said that, try to say that in different ways, but just trying to illustrate the idea or the concept of both the equals operator and the not equals operator. And it just depends on your logic needs. Sometimes when you get into decision structures and nesting and making more complex or sophisticated decisions with your code, you need a not equals. Other times you need an equals. Choice is up to you. I haven't even got to and or yet, but so let's look at this, okay? This is an and we'll talk about logical. All right, so we looked at comparison operators, greater than, less than, equals, not equals. Now we're gonna look at what are called logic operators. And that's these right here. And they also have dashes. And there's and there's or, and there's other states, but primarily the two you will use most frequently will simply be and or. Okay, so in this case, we have another example. And when you see this logical and, this means that both sides of the expression have to be true in order for the test condition in parentheses to evaluate as true. So if I say ground force UNSC equals present and ground force banished equals present, they both have to be present at the same time in order for this condition to be considered true, for it to be evaluated as true. And then this block of code would, in this case would be executed. The flood are defeated. It takes both of them, right? It takes the UNSC and it takes the banished working together hand in hand to defeat the flood. So in this case, the logical and, remember that whatever is on both sides of the and must be true for that test condition to be true. Okay? Now or is just the opposite. Or if we change this to a logical or, only one would have to be true. In this case, if I change it to logical or, this could be true and this could be false, and it would still be considered true. The whole block of code inside the parentheses would still be considered true, because one only says that either this one or this one have to be true. Both could be true too, but it's only demanding that one evaluate to be true. But and, on the other hand, demands that both sides be true. What's to the left of the and operator and what's to the right of the and operator. So if we run this, let's see what happens. The flood are defeated. Why? Because ground force UNSC and ground force banished are both present. Okay? Now, what happens if the banished don't show up? And in this case, the UNSC are left by themselves. The flood escape and eradicate the universe. Okay? All right? So, in this case, the banished didn't show up. They weren't present. And the UNSC, they can't do it by themselves. Okay? So let's change that back to present. What happens if UNSC doesn't show up? If UNSC is not present, well, the banished are here. This is true, but this is false, right? And remember, the logical AND operator that I'm highlighting here that says both sides have to be true. Otherwise, the whole thing is false. Even if one is true, because both are not true, it's false. And so if I run the code again, same thing, right? So if either UNSC or the banished are missing, because we used a logical AND, then in this case, the flood, escape, and eradicate the entire universe. Now, what if I change this to a logical OR? If I change this to a logical OR, now only one of these has to be true. Well, UNSC is not true, they bailed. But the banished showed up and fought against the flood. And, so in this case, this portion is true, and this portion is not. But OR only asks that at least one side of the expression be true. It doesn't demand that both be true like AND does. So if we run this code, let's see what happens. The flood are defeated. Even though the UNSC didn't show up and the banished were all by themselves, the flood was still defeated because we used the logical OR operator. Does that make sense? But again, if we changed it to AND and ran it again, because only one of these is true and not the other, well, what happens? The flood, escape, and eradicate the universe. Okay? And that's all we were saying here as far as using the logical OR operator. Well, I'll do one more example here of using logical OR. All right, so logical OR, right? That means only one has to be true. So let's look at this. In this case, banished and UNSC, they're both present. So if they're both present, then this would still evaluate to be true, and this would still be executed. The only way this would not be executed is, sorry, somebody's texting me about it. The only way this would not be executed is, in this case, if both of these were false. Okay, so I'm just going to run the code. Covenant race forces have arrived. Okay, and what if the banished are not present? No covenant race forces are present, banished, or otherwise. All right, why so? In this case, both of these are false. Now, covenant there, nope, not present. Banished there, nope, not present. Well, because both are false, then this block of code would be executed here. But if either one of these were true, covenant race forces arrive, or if I set this one to be true, covenant race forces arrive. And if I set both to be true, okay? In all three of those instances, this entire expression would be evaluated to be true, and this block of code would get executed right here. But the only time this would not execute is if both were false. Does that make sense? I'm going to turn that phone off. I swear, if that person doesn't stop texting me, I don't know who this is, but... Oh, it's my mom. Okay, sorry. My mom gets... I love you, Mom. Okay. All right. Where were we? Sorry. Okay. I hope my mom doesn't... I doubt my mom will watch these PowerShell tutorials. Please, God, don't let my mom watch these PowerShell tutorials. Okay. I didn't mean that, Mom. I love you, Mom. Okay. All right. Let's see. In this case, let's look at the not. I'll take a look at the not. So we're looking at comparison operators, mathematical operators. Now we're looking at logic or logical operators. So and OR, definitely the most common and very powerful code that you can use in your scripts. Let's take a look at this. Test result. Remember, null is just like an empty value. It's sort of a way of taking out the trash. So now we're saying if not test result. So this is another way of saying, is test result null? Is there no value there? then we'd say this child was not tested, or this child has been tested if it were not null, if it had a value. Okay? So in the first instance where it's null, what do you think is going to happen? And we're using the logical not. So in other words, we're saying if there's not a value stored inside of test result, if test result is null, false, then what? In this case, this child was not tested. Otherwise, this child has been tested. Okay? Now we're going to assign the value tested as a string value to test result. And we'll say if not test result. This child was not tested. This child has already been tested. So what do you think would happen in this example? Test result is no longer null. It's no longer empty. So it would evaluate to be true if we're using the not operator. And so this block of code should be executed. Here we reset it to null. And this is just another way, this is the PowerShell way, -not. But I guess sort of left over from Java and C++, they also let you use the exclamation point. Kind of my preferred method. I like those languages, C++ and Java, just a little bit shorter to say not or not equal to. That'd be a way that you say that. Whereas in PowerShell, you'd say this. But just to show you that you can use that operator in PowerShell, let's go ahead and run this script. So the child was not tested. Why is this code executed? This else block here? Because in this case, it's false, right? There's nothing in test result. It's initialized to be null. That special value in PowerShell. In many other programming languages, it's like nothing. It's like an empty box, okay? And so in this case, yes, it would be true. This is just a shorthand way or method of saying in code, is test result empty? Is it null? If not test result, in other words, is test result empty? Well, it returns true. So this child was not tested, right? Over here in the console, this child was not tested. Here we assign a string value. So now rather than true, this test condition in parentheses will return false, right? This child has already been tested. See? Over here in the console, this child has already been tested. And just to show you that this is equivalent, the exclamation point, to the -not, same thing. If not test result, well, we emptied test result, right? We nullified it. We set it back to null. So it's an empty box. And in this case, that makes this true. And the child was not tested. Okay, let's look at other examples. There are other operators too. Those are the, excuse me, I have to cough. I think I swallowed a gnat. Now I'm going to swallow a spider to eat the gnat, and then I'll swallow a mouse to eat the spider, and a cat to eat the mouse, and then by then I'll be dead. And poor cat. Sorry. Okay, so let's take a look at some less commonly used but still very useful operators. And this is like. Like will do a comparison. So in this case, and we can use it with wildcards. So here we have an expression, are Silence alive? Ask the final 5. So what I want to do is, if I find 5 anywhere in that entire string expression, then that would be true. If I'm using the like comparison operator. So in this case, if we run the code, let's see what happens. Found the final 5, Cylons are alive, okay? All right. But what if there were only 4? What if I changed the value? And even though I'm searching that whole string, the value 4 is not there. So then what happens? You or your mother might be a frackin' toaster. And if you guys are BSG fans, you'd find humor in that. Ty used to always, that's what he used to call the Cylons. He'd call them frackin' toasters. Cylons were these artificial life forms. That's a long story, but all right. So again, here we're just matching a value using the, in this case, the like operator here, and it's just matching a condition, and we can use that with wildcards. So very useful. when you're manipulating strings and searching for values and kind of parsing through a user's input, right? All right, let's look at some other examples. In this case, we'll look at match, okay? And if I use match, let me throw this code over here where we can test it. Kakashi sensei bought Naruto, ramen, Ichiraku. So does the target match Ichi? Then Kakashi Hatake really did buy Naruto ramen at Ichiraku's? Or, if false, Naruto was a bad shinobi. He gets no ramen. Let's take a look at that. So why is it Kakashi Hatake really did buy Naruto ramen at Ichiraku's? Okay. This is true. So in this case, what's match? Well, that's this portion. This portion was found here. So it's like, the dash like, but in this case, dash match, this operator we don't have to use wildcards, all right? And what if I took that portion out and just said Raku? What would happen there? Naruto is a bad shinobi. He gets no ramen, all right? So hopefully that makes sense. Hear my son in the background there. Okay, let's look at another example, and we're going to use the replace operator. And this is actually a method or function, but that's right here. Replace, it's a very useful function. So we can take any portion of a string, search for it as a target, and when we find it, we can replace it with something else, right? So Naruto would love the replace method, wouldn't he? Starts out, Naruto and the nine-tailed fox will become shinobi someday. Well, Naruto wouldn't be very impressed with that. And we're going to say before calling the replace method. But then we're going to replace shinobi with Hokage. And then we'll look at after. And, well, maybe Naruto would be very pleased with those results if we ran the replace method here. Again, I'm trying to step through these relatively quickly. But if something's confusing, you need to go over it, you want to put it into ICE and check it out, and pause the video, and there's just a few lines of code, so type it up and see how it works. Play with it. Get kinesthetic with it. Get tactile with it. That's what I recommend, because I think that's ultimately the key to retaining new information and learning it is to do something with it. Not just watching somebody, but doing. When you do it, it's going to stick with you 10 times better than if you're just watching somebody else do it. But if we run this bit of code here, let me pull the console out here. Okay, before calling replace, matter of fact, let me just add a line of here and a line here and a double line there. Okay, all right, so we'll clear there. All right, so before calling replace, Naruto and the nine-tailed fox will become shinobi someday. After calling replace, Naruto and the nine-tailed fox will become Hokage someday. So very, very useful, right? In PowerShell, to use the replace method, we can target, look for any portion of a string, in this case the string up here on target, and we can replace it with something different. I use that a lot with the Exchange Online. I'll peel off the SMTP off of email addresses and the colon, and just have the user's UPN or email address display. You can use it in combination with split and other methods, which we'll go over. But that's a very useful method in PowerShell. All right, so there's replace. Let's look at another example of replace here, using the replace method. Right, we're using replace. So what are we going to replace? Or I will take the blue pill, just a period and a space. So it starts out with I will take the red pill, or I will take the blue pill. But what are we going to end up with? It's going to basically remove this entire section of the string up here, or I will take the blue pill, and just add a period. Okay, so let's see how that works. Before we call it, I will take the red pill, or I will take the blue pill. After we call it, it just says, I will take the red pill. You follow that? The way it works, replace, okay? You call the keyword replace with the dash. You're going to have an open and closing parenthesis. Inside that, in double quotes, the first part of it, didn't mean to drag that. In double quotes, the first part of it is the string that you're looking for, or the substring. And the second part is what you actually want to replace it with, okay? And those are parameters or arguments, and we'll go over that in much more detail when we cover functions. But, for now, one byte at a time, we're just trying to go through several methods and operators, logical, comparison, mathematical, that you would find useful in your programs. So that's replace. Let's take a look at split. I use this a lot when I build arrays of email addresses and exchange online and build mailing lists and things. It's a very useful method. Split, it's just going to take any string, look for whatever we pass in here that's sort of a delimiter or character or target. So in this case, a semicolon, and it's going to split that up into an array of strings. Okay, so in this case, if we run it, let's see what happens. This is all one string, right? But there's a colon here and a colon here. And so it's going to split it into strings at that colon. And so if I write result, and again, this is also maybe a bit confusing. You're like, well, if you're not familiar with arrays, and if this is your first time programming, you're like, well, what the heck is going on there? This is an array. And an array, you can think of it like a box of boxes, or a collection of boxes, a collection of variables that can have different values or objects. So that'll become more clear when we go through the videos on arrays. But for now, just know that the split method, it's very useful to be able to take a string and break it up into multiple substrings based on a certain value or character. Same thing here. In this case, I'm going to use the parentheses. All right, notice here it was just a colon by itself. Notice the output here. Now, watch what happens when I put this in parentheses here. Okay. Now it's actually displaying the delimiter in this case. So, don't display the delimiter. Display the delimiter or character that you're using. All right, now we can also pass in a numerical argument, in this case to the split method. So there's dashes here, right? 1, 2, 3, 4, 5 dashes. But what if I only wanted to split on 4 of them or 3 of them? Let's run this code here. Oops, my bad. All right. So pony, Pegasus, unicorn, alicorn, Pegasus, unicorn. Why? 1, 2, 3, 4. Okay. And there's the method there. So 1, 2, 3. Now, this will become clear in arrays, but this is a situation what we call sort of an off by 1 or fence post issue. Let's say that I said 3. Well, 3 is actually 2, and 2 is actually 1. Pony, Pegasus. And if I did 1 there, it's like doing no split at all. That's what we call an off by 1 issue. And if I wanted to do, there's 1, 2, 3, 4, 5 dashes, but if I wanted to do them all, I'd actually have to go 1 above. Pony, Pegasus, unicorn, alicorn, Pegasus, unicorn. Okay? And that will become clear. We'll talk about off by 1. That's because things with programming start at 0. So if I were going to do 5, 5 different objects, I wouldn't number them 1, 2, 3, 4, 5. I'd number them 0, 1, 2, 3, 4. Okay? And we're choosing to not dive into that yet because we want to want to try to keep these videos shorter and smaller and break them up into smaller pieces. So let's agree to sort of talk about that when we get to the videos on arrays. Then we'll go into detail about fence post or off by one issues and things in PowerShell. But for now, we'll just kind of let it sit, you know, in that gray area out there. Okay, another example. And let's run using our split method. Okay, and we haven't gone over decision structures yet, but this is just a basic for loop. Okay, and if I were going to run this, you can tell that the result, you know, in this case, the results of the split method, it's not just a string by itself. It's actually an array of strings. So yeah, we started out with only one string up here. I didn't mean for the second line to be highlighted. We started out with one string up here, but when we called the split method, we turned this single string into an array of multiple strings. And we'll go over this most likely in the next video. And we'll look at looping and repetition structures. And when you combine those with arrays, you get some very powerful capabilities where you can do lots of things with just not very much code in PowerShell or other languages for that matter. But in this case, that's just showing you. So just demonstrating that what the split method does is it takes and it creates an array of strings from a single string. Okay, now that's the split method. Now the opposite of the split method is the join method. So if we wanted to, let's look at the join method here in this code. And in this case, we're going to take all of these, you know, as separate values. These are separate strings. We're going to smash them all together, you know, or concatenate them into one single string. So it's just the opposite of split. Some other things we can look at operator-wise. Let's look at the use of n in an expression. So quill, is quill in quill or the Mandalorian? Not in this string, but this string is an exact match. So in this case, because it's in one, think of this as, you know, as if you were using the or, the logical or, right? Only one has to be true. It's not here, but it is here. So it would evaluate to be true. Now, on the other hand, what if we ask, is quill in quill as a father figure and the Mandalorian? Okay. In this case, well, there's not an exact match. I mean, yes, quill is here, but he's not by himself. It says quill is a father figure, not just quill. You understand? So if we run it, let's see what happens. Is quill in the Mandalorian? Okay. Yes, an exact match. Why? In this example, or in this case, because quill, this is an exact match here. This, what we're testing for, matches our target here exactly. Doesn't match the Mandalorian, but we don't care about that. Only one has to be true. Okay? On the other hand, both of these are false. Neither one is true. In this case, he's not in Mandalorian. And even though he is in this string, quill is a father figure, this extra text excludes him because we're looking for an exact match. Right? So again, if I run it, not an exact match. So does that make sense? And so if we go, let's look at this one here. This time we'll look at the contains operator. All right, so instead of n, we're looking at contains. Okay. Now let's see what happens. Cara Dune is a member of Grease Hunters. Does either one of these contain Cara Dune? All right. Yes. In this case, here's a Cara Dune. That contains Cara Dune. So yeah, she was exact match. But then, if Cara Dune is a member of Grease Hunters contains Cara Dune, well, it's not an exact match, but it does contain the expression Cara Dune, right? So let's run it. In this case, is Cara Dune Well, yeah, it matches this expression exactly. All right. It doesn't match this one, but it does match this one. So it returns true. We say, yes, she was. That's an exact match. Now, on the other hand, we're going to say, well, here's the whole string here we're comparing. So does that string, does it contain the expression Karadun? Well, it does, but no, she wasn't. Not an exact match. Why? It wasn't an exact match. Okay. Does that make sense? Yeah, she's in that string, but the problem is we have other, there are other characters in that string. So it's this, to me, I guess you could say the title is a bit deceptive. Honestly, you would think contains, would be whether or not it would be if the pattern is matched anywhere within that string. You know what I'm saying? Like with wildcards or something. But I guess the method name might be a bit deceptive there. But let's take a look really quick at this comparison. We'll throw it over here in our test section. And this is just getting types. Remember we talked about data types in previous videos? Well, the is operator can let you test for a data type. So you can actually test for the type of object something is, which can be very useful when you start bulletproofing and trying to code your scripts to fail more gracefully. Because the end user, they tend to do that a lot. They tend to, you're expecting one data type and they'll give some irrelevant value that's not even what you asked them for, just to see if they can break your code, or sometimes by accident, other times on purpose. But that can be, in this case, a very useful operator method. So if we take a look at it, yes, tester is a data type integer. And it depends on how we declared things up here, right? So if we get the type, how are things set up here? This is an integer 32. And that's this get type method here that will give us the data type of a particular variable. So that's int32. This is a double because it has a decimal value. We start, writing out decimal values of pi. So that can't be stored in an integer. That data type is a double. It's like a larger integer that can hold larger values, both to the left and right of the decimal. And then finally, the string, well, anything in double quotes that's a string literal. All right, so it's a string value. And then we're assigning these values here, and we're just using is to perform a conditional test to see whether or not it matches that particular data type. So yes, tester is data integer type. No, tester is not a double. No, tester is not a string. But when we change the value, yes, tester is a double, right? Because of the decimal value. And the string here, yes, tester is data type string. So does that make sense? These, I put them in dash lines there, but if we look at these three, then hopefully that makes sense. The redirection operator, the rest of these I'm just going to try to go through really quick because my son is being really loud talking outside my door. But in this case, this is the greater than symbol. It's the redirection operator, and it just simply pipes or takes the output of something and redirects it, in this case to a file. So that's a very common thing that we do at the console or in PowerShell. We'll take the output from one method or function or object and redirect it to a text file or some other type of file. Okay? And that's all these examples are going through right here. Just different examples of redirection. We'll go over that maybe at a deeper level when we get into file access. But I think we should cover file access before we cover that. Just another case of is. In this case, we're detecting Galactica, Pegasus, Cylon, Baystar. These are objects stored in an array, which we'll talk about later in a later series of videos on arrays. But just using that is operator. Okay.